What's going on, my friends? This is Dustin Stelzer with Electrician U, and today we finally get to talk contactors. What is a contactor? So a contactor is essentially just a switch, but what makes it special is that it is a multi-pole switch. And what I mean by that is that you can control multiple different things at the same time. So you can control several circuits with one switch, whereas like a regular circuit, you can't do that. You have one circuit, one hot wire you run through here, and then you can control like 7 or 8 lights, whatever. But the other cool thing about a contactor is you don't have to walk up and push a button. With these, they're electromagnetic switches. So an electromagnetic switch, that just means that it is controlled by electromagnetism, by a signal, by current. So you could, there's several different ways you can control one of these, but essentially, say you have like a photocell or a time clock or something, you can have some kind of automatic process somewhere else sending current to these to turn the switch on or turn the switch off. You don't need to walk up and manually push the power. Now, you can do that. You can have a switch be the thing that is sending current to the coil on here, and that energizes that coil and changes the state of the contactor, which allows everything to turn on. But you don't have to do that. You could have a time clock set up, you could have a photocell, you could have some kind of remote monitoring. There's even crazy shit that they can do with Ethernet, where you could just have a signal sent through Ethernet, sent to a relay. That relay controls the contactor, turns the contactor on, and then that turns all of the parking lot lights around on, it turns the signage on and everything. So it's just like much more of a dynamic kind of a switch that doesn't necessarily need manual input. This episode is brought to you by Rogers. So if any of you out there are looking to become an electrician, or you are currently an electrician and you're looking to make that change over to the commercial service world, go check their website out and see what they're about. They're a nationwide company, so they have offices and techs all over the US. So they probably have a location near you. If you're interested in knowing a little bit more about them, there is a link in the description below. The thing about contactors that kind of sets them apart from like a relay, relays, if you remember, relays are essentially the same thing. They're an electromagnetic switch, but relays are typically designed for like low voltage applications or small current applications. So if you're gonna turn on something that you only need like 5 amps or 10 amps worth of current, you would use a relay most likely. But if you need something that's like a 30 amp or 40 amp load, you need something heavier duty, and that's where the contactors come in. So just remember that contactors are like events-driven switches. They're not something that you have to have manual input for. You can have some crazy event somewhere that tells power to come to this thing, much like a relay. So how do they work? Well, they have a couple of different features. First is the coil. The coil inside of here is just that. It is a coil of wire. So inside of here, you have from this lead going inside a just huge coil of wire. If you open this one, you can actually see that. So from one terminal to the other terminal is a huge piece of wire that goes inside. And that coil is wrapped around 2 iron cores. So the iron core, there's one on the bottom, one on the top, but in the middle it meets up. And normally on a contactor, there's going to be a little bit of space in there. And when you energize and send current through this coil, it acts like a magnet. That's what an electromagnet is. It sucks these 2 pieces of iron together. Well, the pieces of iron are attached, in this case, to a plate up here. This top one is actually mechanically attached to this plate. So anytime you energize that coil, it sucks this thing down. And this is a normally closed contact, which means that under any normal circumstances, this thing just sitting on the table as it is normally closed, which means that the leads on, or the terminals on this side are touching the terminals on this side. And when you energize that coil, it changes the state and it opens all of them up. That is a normally closed contactor. A normally open contactor is the exact opposite. So inside of this thing, there's still two cores, there's a coil, and it's doing the same thing. This coil, when it's energized, that copper, it sucks these two iron cores together. But rather than opening the circuit, this actually closes the circuit. It takes the little pieces of metal inside of here and it makes this touch this, it makes this touch this, it makes this touch this. So that is a normally open contactor, and it's very useful. Both of them are needed. There's a lot of situations where you would want one and not the other. The next part of a contactor that you need to know are the contacts themselves. So these are the contacts. This is where you would run, say, a home run from a panel. You bring from a breaker, you bring power right here, and then you bring it out to the field somewhere. So one of these could be for parking lot pole lights, one of them could be for a sign, one of them could be for sconces somewhere, but it's three completely different circuits. So you'd have like a red, a blue, and a black coming in, a red, blue, black going out. But you're basically just using this device to interrupt wires that are going right from a panel out to the field. So these are separate circuits. These are completely separate than the coil circuit. The coil circuit is called a control circuit because that's what you're using to control the device. But it's a way for you to have three circuits on the contacts and one circuit on the coil. Another thing about contacts is each contactor is a little unique in how many contacts they come with. And they're called poles. So like this is a 3-pole contactor. It's got 3 circuits that it can take in on these 3 poles and 3 circuits that it can put out, 3 poles. This is a 4-pole contactor, so very similarly, it's got the coil, the control circuit, then it's got 4 poles. You would take 4 circuits in, 4 circuits out. This old school lighting contactor is set up and configured for it to be a 6-pole contactor, although you could add 2 more sets of contacts and make it an 8. Some of these are 12. They come in all kinds of different types. Lastly, this is a 12-pole. So this beast of a lighting contactor actually has a place for 2 poles on each one of its power poles. So you have 2 circuits in here, 2 circuits out. 2 in, 2 out, 2 in. So this is a 12-pole contactor. Now there's 2 different classes of contactors. There's actually 3 if you consider motor starters, but we're not going to get into that. For all intents and purposes, what we're generally using contactors for, there are electrically held and there are mechanically held. Some people call mechanically held latching contactors, and they call the electrically held non-latching. Whatever you want to call it, the electrically held, all that means is that the only way that the contacts close and open is through electricity. You send electricity to the coil that closes or opens that contactor and either sends power out or disallows power. But the second that you shut something off and take electricity away from that coil, it goes back to its normal resting state. It is only held by electricity, electrically held. Mechanically held is a little bit different. You still have to send an electrical signal to the coil that's going to close or open those contacts depending on if you got normally open or normally closed configuration going on. But once that state is achieved, once those contacts close or open, if you were to take power away from that coil, they're going to stay in the same exact state that they were. And if you try to keep bumping that coil, nothing's going to happen. It's going to stay latched or mechanically held. The only way to unlatch a latching or mechanically held contactor is, if you can tell on this one, we've got latch and we've got unlatch. So latch, you'd send current to it, latches everything. Take power away, stays latched. There's an unlatch terminal down here. You have to send a different source of power to that unlatched terminal, and that is the only way that this thing will unlatch. This is more of like an archaic, basic, but super awesome contactor. This is a super badass contactor, newer style, but you can do the same thing. So there's little leads on here. You'll notice that it says you can put a wire into one of these things. That'll let you latch it. If you put a wire into another one and hit that with voltage, it'll unlatch it. But that's the only way that you get this thing to change states. Now this contactor is a little cool. This is a conversion unit. So without this little block on there, this is just a normally electrically held contactor. It takes, there's no like mechanism in here that would mechanically hold it together. But you can add a conversion kit and stick this on there, and now it is a mechanically held. That you're not running the electricity through here like you normally would. You're intercepting this block, and that's turning it into a mechanically held contactor. That's pretty cool. Now going a little bit further, some of these contactors, usually lighting contactors, not normally these general purpose contactors don't have them, but there's a thing called auxiliaries. Auxiliaries are these little itty bitty contacts that you can insert to kind of add one more power pole or add a little bit of functionality. If you look up here, I've got one that doesn't have a conversion kit and it also doesn't have auxiliaries in it. That's how most of these come. So you have to order one that has auxiliaries or order the auxiliaries for it and put them in yourself. But what a auxiliary does is it gives you both a normally open and a normally closed option. So you can choose to wire this so that if all of these are closing, this one's opening. Or you can do it so that they're the same. If you just need like one more space, that's fine too. This is a 2-pole auxiliary. This is a 1-pole. So you can tell the 2-pole is a little bit bigger, but 2-pole means that it gives you 2 spots. Or if you have like a 220 or 208 or something like that, something that needs to go through and be controlled while the rest of this crazy shit's going on, it gives you another option for it. So that's auxiliaries. Let's talk about the whole normally open, normally closed thing. So all of these contactors, every single one, and all of the relays you're going to come across have normally open, normally closed, or you're going to see NO and NC. You're going to see that everywhere, all over these, and it's hard for a lot of guys to wrap their head around like how to wire something or what is normally open and when is that open. Well, it's open normally, and what is normally closed. I ain't judging you, man. I had a difficult time with this too when I first started, thinking that I was wiring something a certain way and then it didn't work, and then I had to sit and scratch my head. Normally open and normally close. Okay. I said earlier that this is a normally open contactor. What that means is sitting here on the shelf, straight from the factory, de-energized, no electricity applied or anything. This is normally open, and what that means is that the contacts on this side and the contacts on this side are not touching. They're open. It's an open circuit. And they will only close once you send current to that coil. So it becomes closed. Now this is a normally closed contactor. So again, sitting on a shelf somewhere, de-energized, completely just chilling like it is. The contacts from one side to the other side are touching. Right now they're touching. So when you send your control circuit in here and you hit current on that coil, it opens the circuit up. And you'd think that's kind of like counterintuitive. Why would you ever want to open the circuit up? But there is a use for all of these. Some people need things that are normally closed and they need to open up a circuit. Some people need things that are normally open and they need to close the circuit. One step further on that, if you notice a lot of relays will come with normally closed and normally open. This one right now is an 8-pin contactor. That means you can put 2 circuits into this. If you want to know more about these, I have a separate video on that. Feel free to watch it. It's pretty in-depth. But each circuit has an option on it that you can wire it in a normally closed configuration or a normally open configuration. And you can do that on both circuits. This relay is an 11-pin. You have 3 circuits. You can do the same thing. On these contactors, I don't know if you can see this, but on the inside of here, there are little white pieces of plastic that say NO, 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 or you can have them that say NC, NC, NC. You can configure this to be a normally open or normally closed contactor if you want it to be. Same thing with this guy. If you look really close, the 2 power poles down here are kind of like shifted over a little bit, and these 4 are shifted that way a little bit. Well, if you look on the sides of these say NC, 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 and these you can't read because they're being covered. But if you look over here, they say NO, NO, and all 4 of these are covered. So that means that these 4 power poles are set up to be in a normally closed configuration, while these 2 power poles are in a normally open position. So you can change them. You can take the poles, slide them over, take these poles, slide them over. But getting used to when you would use normally open and normally closed and all of that is a huge thing. It kind of like bumps you up a level in your abilities to understand schematics and how to make things work logically. And if you think in like automotive terms, vehicles have relays in them all over the damn place. So with a relay, what you're trying to do is you're trying to think, okay, if I make this thing happen, I can make this turn on over here while I'm able to make this and this and this turn off at the same time. So it's almost like computer logic, if you will. It's a way for you to send current from something, whether it's a switch or whatever, some kind of way to send current to something that it can affect multiple things at the same time, and it can turn things on or turn things off. That's it. That is what a contactor is. That's what you would use them for. That's the differences between them, how the coils work, how the contacts work. The last thing I think is worth note in talking about is kind of like the problems with them that I see. So a lot of times people don't realize what the coil voltage is. They just go to wire one of these things because they see some other contactors in the area and they're like, oh, it all must just be the same. But they don't follow the wires out and realize that all the other contactors, coils, are ran in 277 and this one is run in 120. And so when they're changing it out, they didn't look at the coil that was existing and they just go run 277 to 120 volt coil and then they fry that coil. If you run too much voltage to a coil, it's going to fry it. If you don't run enough to it, like say this was a 208 coil and we ran 110 to it, some contactors, depends on the manufacturer of it really, but some contactors will not do anything at all. And some of them will kind of like slightly chatter, but you're running under voltage to it, so it's not going to last very long doing that, or it's just not going to do anything at all. So make sure that you know your coil voltage. Cool thing about coils is that you can get different coils. So say out in my truck, I've got a 208 coil on this contactor, and I get in there and I'm like, damn it, I need 277. Well, you can take this coil out, go down to your supply house, get another coil that's rated at 277, stick that thing in here, and boom, you're good to go. It's just the coil that you're changing. The contacts themselves, you can't change. I mean, this whole contactor is rated for 30 amps. So this is these contacts are rated 30 amps. Don't start running 60 to them. They're not going to last if you do that. You can run up to 30. You could run 10. It doesn't really matter. But the contacts you can't change. You need to get an entire new body, a new contactor. Another thing to kind of pay attention to is there's stickers, like large stickers on the sides of these that give you extra information about the environments and stuff that you can use these for, or what they're designed for, what they're not. So if you look on the side of this, you can see there's actually a horsepower and a kW chart on here. So if I were to run 115 volts single phase, I could run a 3 horsepower motor on that. If I were to run, I don't know, let's say 460 volts and run a 3-phase motor, I could run a 20 horsepower motor off of this. So just knowing what the stickers are, how to identify the coils, every coil, you can see the coil voltage actually written on it. This one was written here. This thing is stamped right on the top, 120 volt coil. This thing, if you look right underneath this conversion kit, you can see it says 115 to 120 volts, 60 hertz. So they're all rated. You just got to know your coil voltage. So that's pretty much it for contactors. I mean, like, really simple. It just seems really, complex, and especially if you're like in an environment trying to troubleshoot, you're running across problems and you're about to rip your hair out. They seem really complex. But when you start to begin to understand that really all it is a switch that you can run electricity to be the thing that turns the switch on and off, and that you can control several different circuits at the same time, and that these are really for like heavy duty applications, whereas a relay is, kind of lighter duty, and that you can have events trigger these things like photocells, remote monitoring systems, time clocks, things like that, you begin to understand like they're pretty simple in how they work. I think the thing that people mess up most is the whole normally open, normally closed, auxiliaries, knowing which wire goes where and how to do all of that. So I'm going to do another video coming up of how to make a mechanically held contactor like open and close, and when you would use the normally open, normally closed thing, how to latch and unlatch. I'll do another video probably on general use contactors and like, you know, how you would use something like this out in the field. I'll get a normally open version and a normally closed version together and show you why you would use one and why you would use the other and what the benefits are. Just don't have time in this video. So thank you guys so much. I appreciate your attention. I love you crazy people, and I will see you in the next episode.